Okay, I want to tell you about the use of plasma for printing, and I call it plasma for perfect printing, addressing what plasma can do to a surface. A few words to myself. As said, my name is a Dutch name. Van Steenacker is the pronunciation in Dutch. And I'm a sales manager, and I'm an electronics engineer. I've been in the plasma industry for 25 years now, and I've sold all the different kinds of plasma systems which are normally in use in the industry. A few words about the company Tigres. We are a German company. We are a family-based company. And what we do is we develop, we produce, and we sell atmospheric plasma units. So, what do we do? You probably heard about plasma treatment before, and most of you know corona systems for treatment. And I want to tell you what's a corona treatment, what's plasma treatment, and what's the difference between those. So, on the right side, the two systems you can see over here are corona systems. The most known is called DBD, dielectric barrier discharge. This is the standard corona system used for treatment of films to make them printable. A little less known is this corona system. It's mostly used for three-dimensional objects. I will come to that. On the left side, we have plasma nozzle systems. And fun fact is, all of those physically seen are atmospheric plasma systems. So also the corona systems are plasma systems. Because what is a plasma? A plasma, in our case, is an ionized gas. And the gas we ionize is just ordinary air in the most situations. How is it done? In the corona systems, we use an electric discharge which creates the plasma, and the product you have, the film, is put in between two electrodes. Has been used in the industry for more than 50 years now. The newer technologies are the plasma nozzles, where we also create a discharge, but the discharge remains inside the nozzle, and what you can see, what is blown out here, which has a different color, it's white, is a so-called secondary plasma. And this is potential free. So the plasma nozzles can be used to treat metals, polymers, plastics, and a mixture of both. That is very difficult with corona systems because you have a high voltage potential on your part. So they're, let's say, a little more complicated to use. And that's one of the reasons why the plasma nozzles have been so successful in the last 15, 20 years. Okay, so what is plasma used for? We have two different areas, and one important thing is the cleaning properties of plasma. The other one is something we call activation. This is the improvement of the adhesion and the improvement of the wettability, which is not the same. Okay. What is usually treated? Most of what we treat are polymers, and the second one is metals. When we treat metals, it's mostly for cleaning. I will give you an example of one of our customers, and this is a little bit cliche because it's in Bavaria, and we have a company here called Friedrich Richter Messwerkzeugfabrik. No, you shouldn't say that. And what they do is they produce water levels. Okay, and what they do is they have an aluminum frame, they punch a hole in it, and when they do this, they have a lot of oil on the surface, a contamination. And what they want to do with the water level is they want to print their name on it, and a QR code, a barcode, and so on. So what they did in the past, they had these water levels, and they had a guy with a cloth and solvent, and they were cleaning this part all day long with a lot of love. But it turned out it's very expensive, and the quality of the cleaning depends on how the day was for the guy. So they wanted to have a better solution, so they asked us if we can do a cleaning with the plasma treatment for the aluminum, or aluminium as I heard in Britain, version. But they also have some made with a powder coating on top. So this is a polymer. So this is cleaning and activating. It's complicated with one hand. So we had to remove the oil film and also activate the polymer. So we did that. We did it in a lab. In the first step, we saw that it worked quite well. And then we installed, I just want to show you how it looks like. We take 2 plasma heads here. We can cover with 2 heads 50 millimeters of width of those water levels. And then we installed it in the production line. Oh, sorry. And what we then could offer is at a speed of 20 meters a minute to make the treatment just directly before the print. And now it's complicated because I need 2 hands. I have big hands, so that helps. And I guess you can see the difference in print quality. The one above has been plasma treated. The one below hasn't. We will see a picture for those in the back in a few slides. So you can see that the printing quality from the wettability is much improved, and I can also say the adhesion is much improved. Okay? So that was the example, and now I want to dive with you into the details. We will do a quick, short round about that. So let's have a short look at adhesion theory, and I will make it quick and simple. There's not 1, but 5 mechanisms of adhesion. And for us, interesting is number 2, the so-called secondary valency bonds. And here, it's mainly the van der Waals interactions. They make the difference in wettability on the surface of the polymer. And this is very important, obviously, for inkjet printing. But we also have mechanical clamping and diffusion. And this is, at least until we know now, the most important part when it comes to the improvement of the adhesion. And there's also something like electrostatic forces. And fun fact, when I did the research for this presentation, I found out that the gecko, which we thought it was using van der Waals interaction, which it does, also uses electrostatic forces in its paws to climb on walls. I didn't know that, but okay, fine. And all the mechanisms you can see here are working at the same time and can have synergistic effects. So this is what we are looking at. When we look at the secondary valency bonds we just saw, we can see that when we have a polymer like a polyethylene, which is very difficult to print at, the pre-treatment with the plasma changes the chemistry at the surface. So we put in a lot of oxygen. And the oxygen is what increases the surface energy of the polymer. That means the more I treat the surface, the more I increase the wettability. And here again, the water level, you can see it here very clearly now. The one which has not been plasma treated is very, let's say, not so nice. And the one which has been plasma treated has a very brilliant color or print. And the difference is that the wettability improves with the plasma treatment. So the single droplet gets a bigger area on the surface and can overlap more easily in contrast to the non-treated area. Okay, but that was wettability. Now let's come to adhesion. When we look at the values of the wettability, which is created from the secondary valency bonds, we see it's very, very small. It's almost nothing. But when we look at something which is called entanglement, we see that the value is very high. Okay, so what is causing entanglement when we treat a surface on a polymer? When we look at the polymers we normally treat, like you can see here, we have crystalline structures in the surface. And these are very difficult for the ink to penetrate. And what the plasma does is it changes the structure of the surface from crystalline to amorphous. And then we get a more or less open structure in the surface, and here the ink can penetrate and then harden, and then you have a very good adhesion. So wettability and adhesion is not the same. Now let's put all together. This is important when you have a project where plasma treatment is being used, so you know what you're doing. Okay, what do you see here on this picture? We have here a customer who wants to achieve a value of adhesion of 45 Newton. And we see the wettability going up with the plasma treatment to a certain level. In this case, 72, so it's water. And what we also see is that the adhesion goes up with time, with the treatment, to a certain level. And the first area here I call insufficient treatment because it's below the level the customer wants. But you also see that the curve is going down again if we treat too long. This is called overtreatment. And what I want our customers to do is to find this sweet spot, the effective range, where the adhesion is in the range the customer needs. And if possible, he should try to aim for the optimum point. Okay, now we take the same picture with different values. Now we go from 45 to 20 Newton. And what we see is we still have a little bit insufficient treatment at the beginning of the treatment, but then we have a very huge effective treating window. So it depends on the application and the treatability of the material, how you have to treat your application to get good results in adhesion. Very important. The problem we very often see is that people have some kind of corona treatment or plasma treatment, but they don't know what they're doing. And that's why they can have overtreatment and sometimes ruin the process without knowing it. So how can you adjust for this plasma dose, as we call it? Oh, I forgot this slide. What is overtreatment? Overtreatment is when you treat a polymer, it's a different thing on metals. When you treat a polymer, the plasma will create so-called low molecular weight oxidized materials or debris, polymer debris, from the material itself. And that is very nicely treated. It has a very good wettability. And that's why I say wettability and adhesion is not the same, because here you will see a very good wettability. But when you try to pull on the ink with the tape, for example, you would see that the adhesion goes down if you have too much of those debris on the surface. So that's overtreatment on polymers. So how do you use a plasma system to have the best possible results? There are three different possibilities. When using plasma nozzles, you can adjust for the distance of the nozzle to the surface. That's quite easy to do, but the problem is the window you have is very small. So it can be done, it's not the best way. What you also can do is change the treatment speed. But not in every case that's an opportunity or a possibility to do, because not everybody wants to adjust the treatment speed of the product or in the production. And what we can do with the systems we build is we can adjust the power directly on the plasma nozzle. And that sounds quite obvious, but most systems are not really good at that. And we designed our systems to be able to adjust this plasma dose very fine on the generator. So that looks like this, for example. We have here the different systems we can offer. And we have here the plasma dose. And you can see that each system has a range where you can adjust the plasma power. So we take the system which is mostly suited for the process. Okay, conclusion. A good wettability is important. So that is normally happening when we treat a surface with a plasma system. But in itself, it's not sufficient. And for the optimal test results, we normally say, okay, try to find out where your optimal dose is. Where do you get the best adhesion with the best possible wetting? When you have power adjustable plasma systems, it's very easy to do it. Otherwise, you have to adjust speed or distance of the nozzle. And most importantly, proof of adhesion is necessary in the application you're doing. It's not enough to use a testing or even also not a contact angle measurement. It's not enough. It's important to test the application with the parts of the customer. Thank you very much.